talking about a program here that's going to change the way your company manufactures, big time. And just like the room, make sure you know what you're getting into. Understand it. Make sure there aren't any hidden things that you don't know about before you enter on such a program. And that's part of the reason I'm going to walk through this with you. You're going to actually hear the details of this. So it's day one, ready for the big day. Everybody knows about it. You got your team put together. You got mission control. Everybody gathers. First thing in the morning, we're ready to start. First thing you got to do, 7 a.m., we're going to kick this off. This is these charts. A little bit hard to follow, but there's a lot of activity here. What we have are 4 teams. Each one is doing activity over a timeline. Starting at 7 o'clock, the operations team, planning and control, procurement, and demand. You've got to kick off the day with a pep talk. You've got to get people really fired up about wanting to do this. And they've got to understand the details of it. You've got to build what you call instant consensus. You can't wait around for people to finally say, yeah, this is a good idea, I like this. You've got to get them fired up fast, so hopefully they're there. One thing you might want to do, just to differentiate everybody in the team, is wear kind of a little outfit. I recommend these JIT Happens in 48-hour sweatshirts. Everybody puts one on. So everybody who has one of these shirts on, you can see they're part of the plant. I mean, they're part of this program. They're making it happen. So that's one thing you can do. But you got to build that instant consensus. There's a program I believe in, because I created it, so I should. It's called ROAR, and this is how pilot projects should start. I believe that it's critical that pilot projects start with a ROAR. And what that means is you want to choose representative production. You want to do your pilot projects with products, in this case the gumball machine, that represent your production. If you're a telephone manufacturer, you don't want to start out with your light line, because that's not what you do. You want to start out with something that's very representative of your plant as a whole, so you can extrapolate the results to other things. You want to pick an ongoing product. You don't want to pick something that you're going to phase out. There's no point in spending a lot of time implementing JIT for a product that you're going to get rid of then. You want to have a product that has achievable goals. You want to set goals that are important, that you want, that everyone will be impressed with, but they've got to be achievable. You don't set goals that can't be achieved so everybody can turn around and say, well, they didn't do it. They didn't achieve it. But don't set goals that are so wimpy that no one is impressed with them, like a 2% reduction in inventory over 6 years. And then finally, you want to do something you can do at a reasonable cost. You don't want a pilot project that forces you to spend millions of dollars. You want a kind of a self-funding project. Spend your money, do something where the inventory savings, the lead time reduction, the floor space reduction that you achieve in a short period of time pays for the costs of doing it. The project should start with a ROAR. And what we're going to do here now is start walking through what is actually happening. 7 o'clock, you have the pep talk. 7:30, the 4 teams hit the floor. They're off on their own. They're doing their thing. The operations team is going to start out for the first couple hours doing what I call a routing by running around. Usually we call them routings by walking around, but in 48 hours you got to run. So what you're doing is you're going to take the product, in this case they've chosen the gumball machine, they're going to follow it through the whole plant very quickly to see what is involved. And here's an example of a routing by walking around. You follow it and you see, how is this product made? Where does it go? Where do all the pieces come together? And you frequently find you're traveling tremendous distances, even miles sometimes. I'm working with a nuclear bomb plant that parts on average go about 7 miles in production. So in one facility, in one location. So you follow it around to see how far you're actually going. And that's what they're going to be doing. They're going to get an understanding of the reality of this product. Don't believe your engineer's process routings that say it gets done here, then here. That's not how things really work in plants. Follow it through in your hour and a half and understand every part of the plant that's involved with making the product you're working with. Then you want to do this, the planning and control group is spending that same time doing a work in process lead time analysis. They're following the product through, trying to understand where is the work in process accumulating, how much time is it actually taking. Remember the pizza example. You got a pizza that you can make it in 30 minutes because that's all it takes to do. You got a product, you look at each operation and say, how many minutes of production do we really have? How long does it take to make this product? And then look at your records and say, how long does it take? What is our lead time? From the time we start it to the time it's ready to ship, what is it? How many days is it? How many weeks is it? But also find out how many minutes or seconds it takes to actually produce the product. That's what they're doing in their first hour and a half. The procurement group, now remember, we're starting at kind of a general level for the first few hours of 48 hours. We're trying to focus on one product, one specific aspect of it. The procurement group is looking at purchasing. And what they probably need to do is sort of an ABC analysis of purchases. They need to understand what it is you're buying, because you can't focus on everything. Maybe in this company they'd probably be buying the castings. These are castings. They'd probably be buying some steel. They'd be buying these, probably be buying these globes. They would, most likely they wouldn't be making them. Maybe some screw hardware. But you look at what you're buying, what's significant, maybe rank them in total dollars. Maybe you want to choose the most valuable items to focus on. Maybe rank them by commodity. Like you could call castings a commodity, and you could rank them that way. Maybe dollars by vendor. Maybe one vendor is providing enough to be your most significant vendor. You could rank them by lead time. Which are our longest lead time items? Those are the ones we want to work on. If castings take 16 weeks, maybe you need to work on the castings. You should also look at any quality issues you have. If you've got purchase parts that are a lot of quality problems, maybe those are the ones you've got to focus on to make just-in-time work. But that's what the procurement people are doing in their first hour and a half. The demand people, they're looking at sales. They're looking at what is our dollar volume? What is the trend of sales? Is there seasonality? Is there, how do our customers rank? How do we deliver to our customers? What are our sales terms? Terms are very important. A lot of times companies are in a bind with the way they manufacture. They tell me, I can't manufacture in small batches because my customers order in large batches. And I ask them, do your customers want things in large batches? Does Kmart, where's my bat? Lost my bat. Does Kmart want 100,000 baseball bats on one day? Probably not. I mean, that's what they say they want, but do they really want them? Probably not. They probably would rather have small batches delivered during the season. If it were efficient, they'd probably want them delivered in small batches to the stores if they could. A lot of times the terms, your sales terms dictate how customers buy the product. You induce your customers to buy large lots, and then you complain about having to make large lots. Quit inducing them. Induce them to buy small lots, and maybe they'll buy small lots and find that's really the way they want things.
Kmart and some of those places, Walmart, I'm not trying to just pick out certain ones, but those people order and they want their shipments, say, shipped in November, December, January, so in a 3-month period, and so we have to store ahead of time for shipment later. And so again, if you do have a customer comes in once that's out in a short period of time, the small loads do you a little bit better response time to the demands of the customer.
And then look at the margin. Maybe you want to focus on the products that have the best margin or the worst margin, and whatever makes sense. So that is what the demand team is doing. That's what the 4 teams are doing for the first hour and a half or 2 hours, and that brings us up to 10:30 or 10:45. Now the core group gets together. One representative from each group, and they sit down and they decide for sure which product are we going to focus on. In this case, they've chosen the gumball machine to focus on. This company makes other products, Acme Widget. They've chosen to focus on the gumball machine. And they know each of the teams has a good idea on what the issues are, what the problems are. So we're going to go on from there. It's 11 o'clock. Now let's focus in a little more detail on the 2 teams, the operations team and the planning and control team. The operations team is going to start to look at setups. Let me skip a couple of these. The operations team is going to start to look at setups. And setups are very, very important. Setups, frequently it's the setups that determine your batch sizes. And you want the kind of flexibility, you want your machines to kind of be like this guy, to be able to go in any way, do what you want, when you want them to do, fit anywhere. The key to setup is to get them down to the point so you can manufacture in the batch sizes that are right for your demand. That's the key. And setup reduction is a complicated job, but it's not as hard as it seems, and the results are staggering when people do it. In almost every case, setups come down 70, 80, 90% just by focusing on the simple things.
But now, like Kevin, he had 96 batches, instead of 432. Well, we worked as teams, as a team, and we came up with 180, which was right now, it's what we've been running for right at 2 years. And it's a good batch load. Maybe later on we can go lower, but right now it works good for us. But a person that's going into it is just, you just got to open your mind. You think, well, I'm going to be out of a job, and it's not going to work.
And frequently I tell people, don't even start on the machine setup itself. First of all, do what I call the 5 Ds. First of all, figure out, can you deproliferate the products you offer? If you offer 50 different products, if you could cut those down, you wouldn't have as many setups as you do today. Work with your design people or with your marketing people to see if you can reduce the number of products you offer. And you don't want to hurt your marketing efforts, but if it's not going to hurt, then by all means go ahead and do it. Work with engineering to see if they can design products in such a way that they're simpler so you don't have to set up for each product. I worked with a machine tool manufacturer, and the back of their electrical panels had holes drilled specifically for each product, and that required setups on the drilling equipment. What design was able to do was to say, let's come up with a common back for this electrical panel, and now everything can use the same one. Once you've gotten as good as you can with those two things, then figure out what your daily demand is. What do you want to make every day or every week, whatever makes sense? Does that mean you want to set up 4 times a day, 10 times a day, 20 times a day, once to twice a week, whatever makes sense for your business? Figure out what that has to be. Then figure out if there's any options of dedicating equipment so you don't have to do setups at all. And once you've done that, now you know what your setup times have to be. If you have to do 4 setups a day and you figure out you run one shift and you have 7 hours of capacity, you need 7 hours of production capacity, that leaves an hour for 4 setups. That means your setup has to be 15 minutes, regardless of what they are today. I don't care if they're 3 hours, they got to be 15 minutes. Turn your people loose, and they'll figure out how to make them 15 minutes. They will do it, and it doesn't necessarily have to cost a lot of money to do. So that's what that operations group is doing. They're looking at setups. They're saying, which are our biggest setup problems here? Is it a machining problem? Is it an assembly fixture? They're going to focus on specific setups for this gumball machine, prioritize the most important ones, then they're going to videotape them. They're actually going to ask the operator to do a setup, and they're going to videotape them. And when they're done videotaping by the afternoon, but before the first shift goes home, they're going to meet with that team and start the review. They're going to watch the videotape, and they're going to ask the operators, why are you doing that? How could you avoid having to do that? They're going to focus on the simple kind of things. Why did you have to leave the machine for half an hour? Where did you go? Why didn't you have the hammer that you needed? Why did you have to wait for a fork truck? Those kind of basic things that frequently are the biggest components of setup time. And then when they're done with the team review, they're going to be able to make their first assessment of setup reduction, and hopefully before 5 or 6 o'clock, when the stores they deal with, the suppliers they deal with, they're going to order any parts that they might need to make changes to the equipment. Get those orders in so they can start working on them the next day. Meanwhile, maintenance operations group is also working on maintenance activities, focusing on maintenance problems that cause downtime, that cause just-in-time not to work, looking at downtime, looking at scrap, at leaks, at adjustments, at tool wear, the kind of things that obviously you can't rebuild a piece of equipment in 48 hours, but you sure can start looking and identifying what those problems are. And they're going to do that. They're also going to take that routing by running around they did earlier and flesh it out, go in much more detail while part of the group, while they've got spend most of the day there going through and really trying to focus in on the problems. What causes the lead time to accumulate? Why are there buffers where they are? What would happen if there weren't a buffer there? Planning and control is going to start looking at equipment capacity to understand what do we have capacity to do, and there's a lot of reasons for that. You want to be able to build the way you order. You want to be able to build the way your customers order, and that means that that your equipment has to be able to handle that. If you've got a seasonal business and you have tremendous peaks like baseball bats, then maybe you are going to have to do some limited build to stock. Maybe there are other times when you won't be able to keep up with capacity. The point is under just-in-time, you don't run your machines at the rate the machines run. You run them at the rate your customers buy. And that's what you have to understand. And that's why you need to do the equipment capacity. You need to understand the way they're loaded, the way they're attended, the downtime issues, the interchangeability of equipment. Can something we're now using for this be used for something else, or vice versa, to support the production here? So somebody's got to understand that equipment. And the goal is, once you understand the equipment and the lead time, you can come up with a strategy. You can come up with a production strategy for how you want to manufacture.
Some areas work a little bit past those. Our machines work different areas. The lathes run different speed than our sanders run different speeds than our branders, and so on and so forth. So it's not just a continuous pattern going through, where everything you just hand it to the next person. So
Planning and control group has to analyze the production control procedures. They've got to understand And this is not an easy task, let me tell you. Somebody's got to understand how does production control work. And that is a hard thing to understand in most plants. Rube Goldberg was famous for coming up with these inventions that use maximum input for minimum output. That was his goal. When you see production control systems, you'd swear that he designed most of them. They're incredibly complicated to do what is basically a very, very simple thing. And the scary thing to me, the really scary thing, is that the same people who design these production control systems, now they want to automate them. They want to make them automated, and even scarier, they're now talking about artificial intelligence, so you can let the computer now make all the decisions. And boy, is that scary. I did an example once with a group, which I thought was very illustrative. We were talking a little bit about expert systems and artificial intelligence. And I said, okay, let's do an example here. Let's, as a group, come up with an expert system. Let's design an expert system. Let's take something that we're all familiar with, which is going into a public restroom and deciding whether or not you're going to use the stall. And I said to this group, what are you going to base your decision on, whether or not you're going to use it? Let's come up with all the rules. We'll design an expert system. And they said, okay. They started thinking things. There's got to be paper there. They'd like it to be clean. The door should have a latch. Hopefully it has a door. The floor is dry. The toilet flushes. Maybe there's a coat hook. These are kind of ranked in order, what they thought was the ranking of the rules they would use. So when we're all done, that group, we put these together, and everybody said, those are the rules. If I were designing an expert system, that's what I would base it on, those 7 rules. The thing that nobody ever said was whether or not it was occupied. And to me, that would be first on the list. I mean, I would put that ahead of everything else. But nobody thought about that. And it kind of illustrates the danger of expert systems, of relying on computers and rules to make decisions for you. There's a lot of risk in that. You have to be very, very good. And these same people who design these complicated production control systems are now trying to come up with expert systems to do it. What's important for this group is to understand how it is and just streamline it. Make it the simplest system you can. How can you get rid of the need for computers for complex instructions? How can you make the shop floor run itself visibly? Meaning, I'm an operator, I see that there's more work required, so I feed a small queue or a small buffer. And that's my only signal. No one sends me a report. And in order to do that, I take material from somewhere.
Initially, we knew nothing about just-in-time. At the time, on our staff in here, we had 3 other former supervisors on the floor that worked with me putting together the dimming activity. Together, we learned what just-in-time was all about. We did sort of a self-teaching. We then were able to put together a training program for all of our employees in the BAD department. We made a facsimile of the BAD department. We brought employees in small groups, and we actually walked them through the entire just-in-time process in the BAD department from start to finish before we actually took the thing on the floor to begin with. I think as a result, that was very good exposure for them. It reduced any fears that they might have. And as a result, I think today our employees in the BAD department are just as knowledgeable of what just-in-time is all about and the things that we're trying to accomplish as are any of the rest of us at this particular time.
Think of grocery stores. Grocery stores are the greatest example of what we call pull scheduling. You go through a grocery store, you take some Oreos, you take some cornflakes off the shelf. A stock boy eventually comes back through and sees, oh, there's an Oreo missing. He puts it on the shelf. There's cornflakes missing. Puts it on the shelf. He didn't need any kind of schedule, any forecast to do that. He just filled a hole. There was a very small hole, and he filled it. And that's how supermarkets can turn their inventory over so quickly. But these guys are understanding that system, and they have all day to come up with a streamlined production control system. What we have here. Paperwork is very, very critical. I mean, paperwork is so critical, and you've got to understand what's going on with it, because you want to get rid of it all. I saw this quote in the paper, which I think is wonderful. This is the guy who is the head of the largest machine tool company in the Soviet Union, and he said, it's not enough to get rid of the paper, you got to kill the people producing the paper. And he's right, because they'll produce more forms faster than you can get rid of the next batch of them. If he were in the U.S., we'd hire him, because he's got the right idea. So you got to chart that paperwork, understand it, and challenge every piece of it and say, why does this need to be here? How can we get rid of this form? If there's a form to tell somebody something, why do they have to be told? Why can't it be visible? Why can't it be obvious? Why is data you need at all? So they're doing that. They have to understand the procurement cycle, the strategy behind procurement. And the goal here in the procurement side is to be able to actually contact your suppliers by the end of the first day, to figure out what procurement items you want to focus on, how you procure them, what you want, what your strategy is, and then by the end of the day, from 3 to 5, you start making supplier calls to selected suppliers, telling them, this is what we're going to be doing, and this is what we want to improve the way we work with you. What do you recommend? You got about 2 hours to do some conference calls with your suppliers, and then you get together and summarize the results of it. Because that night, you're going to pick which suppliers you want to focus on. You can't do a lot of them in 48 hours. Meanwhile, the demand group is doing a detailed analysis of the way people buy these gumball machines. And I tend to look at 18 months because you want to pick up trend and seasonality and all those other things that are important.
We are in a very competitive position. The market can swing on the cost of a penny. So we have to position ourselves that we can respond to that customer's need with quality, with service, on time. And the only way we've been able to do that, in my opinion, is to work closely with the customer, discuss lead times, get the product into our plant that he wants, make sure that our people understand what it is the customer wants, and then provide that product and service on a timely basis. We've adopted, we have 6 operating plants. We've adopted just-in-time in 4 of those plants. 2 other ones are now under study to be put in the just-in-time mode.
There's sort of a 3-pronged approach to demand strategy. One thing you want to do is come up with smoother sales. If your sales are up and down and up and down, you want to look at anything you can do to smooth them out. Most companies tend to say sales are the way our customers buy, but I do believe that you can influence the way your customers buy. I think there are options, and maybe the bad example is a good one. You go to somebody and say, you ask for 100,000 bats on one day. That means we have to build them that whole month before. Couldn't we spread that 100,000 out into 10,000 orders over a 3-month period? And if they say yes, then you've got a lot of opportunities. So you're looking to smooth sales as much as you can. You're looking to simplify the products as much as you can. And that's why you've got your design people here. And they're looking at this gumball machine saying, how can we design this to be simpler? How can we design it to take away options so you don't have to set up for them? And in this case, they might want to focus on the coin mechanism. They might want to focus on the fact that they have to make 3 machines, one completely different machines, one for pennies, one for dimes, one for quarters and nickels, whatever it was. And they want to make that simpler. So they're going to focus on that. They're going to figure out, is there a way we can have a mechanism that can, at the last operation, can be converted to whatever coin it is, so we can build identical gumball machines to that point and then pop in the mechanism, and it's the same. Meanwhile, the marketing group is looking at the proliferation. They're looking at all the colors. They're saying, we offer red, we offer green, sell a lot of green ones at Christmas, and we offer yellow and blue, and we offer big and little. Maybe some of these we can get rid of. So they're assessing what they believe would be the impact of getting rid of those things. And they have until about 3 o'clock, then they can all meet and develop this demand strategy, this detailed demand strategy. That this is our 3-prong approach to changing demand to support manufacturing. Now it's 7 p.m. I forgot to put my sun up before. This is kind of a reminder what time of day it is. Must have been a cloudy day because the sun wasn't up. But now it's night, and now the moon is out. It's hard to figure out when you're in the plant what time of day it is. So now we know it's all night. 7 o'clock, the moon is out. The operations people are focusing on their preventive maintenance program. They had dinner. They pulled a lot of data together. They're focusing on preventive maintenance. What can you do in 48 hours? You really can do a lot. It would be surprising. You can't do everything, but you can set up a very simple lubrication program. And I've set up lubrication programs so simple that they were totally color-coded. Somebody did not even know how to read, didn't need to know how to read to make them work. You looked on a chart and a day with a red dot. You took the can with the red dot on it and dumped it into the red holes, and that was it. Because there are plants where literacy is a problem. You can do basic kind of cleanup. You can establish needs for spare parts. What are the critical items that need to be there for a good maintenance program? You could do some simple rebuild activities. I'm not talking about taking a machine apart completely and rebuilding it, but there's parts of the machine that could be rebuilt in a 48-hour period. Getting a lot of operator feedback, you could set up the mechanism for that. That's part of a PM program, capturing feedback from the operators. And then finally, you could develop a schedule for preventive maintenance. All of that can happen in a 48-hour period, and that's what they're doing. They're developing that program. They're planning for improvements of equipment. And why not start the equipment cleanup? Why not have a night crew, if it's a two-shift operation, come in, or if you're going to use outside people, start cleaning up the equipment.
If I was to offer advice to someone starting just-in-time program with, and I hope that they intend to use their employees in the process, because without it, they will not be successful. Some of the best ideas that you're going to generate come from the factory floor. So make your employees aware, include them, have them participate, make them part of just-in-time. That'll speed your end result up, and it'll make them much happier employees.
In a lot of plants I've been in, the equipment was so dirty that in some cases you couldn't even find the lube points on the equipment. In all cases, when you've got filthy equipment like that and you tell an operator to do a quality job, what is it telling them? You're saying, we want the best parts for our customers, we want you to do a good job, we care about you, but you've got to work in this awful, filthy environment with this filthy piece of equipment. Clean up the equipment, and you can, in a night, these guys who do steam cleaning can come in, they can do a lot of equipment in a one-night time. So don't discount how much you can get done in a short period of time.
It's not you work on the problem and I'll watch. So it's, from that standpoint, I really like it. It cleans up the place. And it allows us to service our customer. It allows us to react to our customer, because we don't know from one day to the next what a customer is going to order.
These cells, when I talk about cell strategy, cells are sort of the traditional way to structure equipment in a just-in-time environment. And it's driven by the fact that most plants, in traditional manufacturing plants, machines are set up functionally. And that means that you have all your mills together and all your drills together and your presses are together and everything's together. And there was a logic to that back in the 1800s when machines were driven off common drives. But for the most part today, pieces of equipment are standalone. They have their own hydraulics, they have their own scrap systems. All they need is electrical and oil and steam, and they can run. So equipment doesn't need to be that way anymore, but that's still the way you find it. And this inhibits the flow of product. It takes a long time to make products because parts flow through. Parts which need to go in each machine sometimes have to go from building to building, and that's where you get the 6 or 7 miles accumulated. The goal in a just-in-time program may be to cluster your equipment so products can flow through. Maybe all the machining and assembly on this could be done in a common flow instead of having a gumball assembly line and having a machining department that does separate things in isolated areas. Maybe paint is very separate. You can't always do this. And I've implemented just-in-time where we didn't move anything. With the liquid detergents plant, we didn't move anything. It didn't make sense to move anything. With the machine tool plant I work with, we moved very, very little equipment. It didn't make sense to move a lot of it. You move equipment to impose a discipline or to minimize the handling, to minimize the movement of material. In a low-volume environment where you can impose the discipline in other ways, maybe it's not worth moving the equipment. In this environment, maybe it would be. Assembly lines are typically very easy to move. They're bolted to the floor at best. And I'm not talking about automotive assembly lines, but assembly lines for light products like this, there's not a lot to move them. So you definitely want to look at the possibilities of doing that.
Primarily, I think the biggest problem we had with people, even the believers and non-believers, was being used to having so much space all around them. And all of a sudden, we start setting machinery in little cells, and the initial reaction from both sides, believers and non-believers, was this is too close. That we put in a trial cell and let the people themselves dictate how much space they needed with a guideline on how much in-process inventory we wanted, and then they began to see that hey, this is not really too close, it'll work fine.
The planning and control group, meanwhile, is developing the pull strategy. And pull is a fundamental part of just-in-time, and they're going to be working on how, instead of having schedules tell everybody what to do next, how can you have a very simple, visible pull mechanism to do that? And when I talk about pull, the purists will say, well, you've got to pull one piece at a time. That's not true. You can pull a lot of things. You can pull pieces. You can pull batches, whatever that happens to be. Maybe your batches will be smaller than they are today. You can pull containers. One container can be the thing that you pull. And that's a very logical thing in most plants. You can pull orders. Maybe you pull an order at a time. Orders maybe are close. In a pizza place, they pull an order at a time. They don't pull an order equates to a piece, but if somebody orders 2 or 3 pizzas, they're going to do all those together. Sometimes where you don't have repetitive production, you might want to pull hours. You might want to say, okay, I'm ready for more work. I'm going to look at the first in, first out list, and I'm going to do 100 hours. So that means I'm going to do the first 5 jobs. Because somebody sent me a signal which meant I'm ready for 100 hours more work in my area. You have to be very creative. I've done work with a beverage company. They make beverage cans for the beverage industry. Tremendous volumes, make billions of them, 2 billion cans out of this plant. And we've set up a truckload pulling operation. They were spending a lot of time and effort trying to figure out how to stock the warehouse so they could, and how to get communication from the beverage people so that they would know what was coming, know what the truck wanted. And instead, I've taught them that forget about all this communication. They never know what they want anyway. Even when they tell you in advance when the truck pulls up, they don't know which cans they want. Set up a very simple system so you have a little bit of everything. When the truck comes in, fill the truck with whatever he wants and replenish it very quickly. So they're pulling truckload quantities.
You don't have inventory sitting all around, and to me, when you have inventory sitting around, you have money tied up that can be used in different areas of the company. And it's been proven that we've had more orders than we've had last year, and that we are servicing our customers with the just-in-time program because we're working on a pull system now, which it pulls and it goes right on through the BAT department, right on back to the shipping, and right on to the customers, and we're meeting our customers' needs this way.
The first one is, in my mind, is the result of understanding what the reduction in work in process means to us and to our customers. We had first thought about reduction in work in process as strictly an accounting function and how many dollars we could save in our pockets. And then when we actually started doing it, when we took our inventories from 5 weeks, our work in process from 5 weeks worth of production to 2 days worth of production, we found that we could do amazing things with our scheduling, that we could turn our product schedule around on a dime. And we were only inhibited by our suppliers, what they could give us, and that we could react to markets like we had never reacted before. We didn't have that concept at all when we first started. We didn't think in terms of 2 and 3 day turnaround from start to finish of a product. So we didn't even dream in those areas. But now that we do, we can see the advantage that we have over our competitors. With different products that we can make and get to the market before they can. It helped us to focus in on what we think now is a prime goal of JIT is to continually reduce work in process.
Pull can be anything. The way you pull, there's lots of different ways. People put squares on the floor where you just tape or paint a square and you fill it. And when someone takes something away, that's the signal to fill it again. People use containers as the signal. When the container is empty, you give it to somebody, that's their signal to fill it. People use, in the golf club plant that I work with, we actually use a color-coded golf ball rolling down a pipe to the other end of the plant where that's their signal to start it. And in fact, this is a good illustration of visibility. I worked with these people a long time, and I stressed to them, you want visibility. You want things to be obvious. And we designed this system so there'd be a PVC, some pipe running down the plant. And when I came back the next week, they had put the PVC in, but instead of white PVC, they had put clear PVC in. And I said, oh, that's interesting. They said, well, you keep telling us visibility. Now we can see the ball before it even gets there. We can kind of see it rolling down, and it almost becomes kind of a competition to see if you can start pulling the material before the ball gets to you. It was slick, and they took that visibility to heart. The signal can be electronic. It can be a light bulb. Sometimes you just turn a light on, and that tells somebody that you need another rack or whatever it's going to be. You could use some kind of a card, but in Japan they use the kanban, so I mean that's the tradition. That's all it is a card. The card is a better word to use. Kanban has more letters. See how efficient it is by using the American term? So that's what these guys are doing. They're going to design the pull system. They're going to come up with the details for it, and that night, before morning hits, they're going to actually implement a pilot pull. And in this case, maybe it'll just be a square on the floor. Maybe it'll just be some painted areas or some taped squares on the floor. They're very flexible if you want to change them. And so when the first shift comes in, they're actually going to start pulling. Pulling is very easy to do. You can start it right from the beginning. You'll have problems, but you can start it fast. So that's something they're going to accomplish by 6 o'clock in the morning.
And when we initiated the JIT system, we started out with one area pretty much, and that was our turning area over here. And we actually marked the spots. As you know, the JIT is a pull system. So at our lathes, we had actually a green and a red spot. They'd pull the timber in on one side, it'd be turned and put into the red area, and from that point it'd be pulled to the next operation. And from that point on, then we added the other departments into it within just a matter of a couple of days from that point. I think the future JIT here at Glasby is very good. I think that it is improving all the time. Each year we seem to improve on it, and we find faults with the time, and we make changes. Now, the faults are usually because, as I said before, because we need to add an extra Kanban area here or there because of the way our machinery is set up and does not run at the same speed.
Let's go on with procurement. They're working this is 7 o'clock again, still the first day. Procurement is brainstorming all the data they've gotten. They've talked to suppliers. They just got off the phone with all these different suppliers. They're trying to figure out who they're going to deal with. They want to get this down to maybe 1 or 2 suppliers for the 48-hour period that they're going to work with to try to implement changes. They're going to try to streamline the procurement paperwork process. Why does it have to be so hard to procure more material? You're doing it over and over again. How can you simplify that process? They're going to try to understand the demand characteristics and when people are buying what they're buying. And they're going to establish goals for a vendor partnership. And a vendor partnership is just like mom and apple pie and the American flag. It's just basic kind of things. And it's very hard for people to do, but this is all it is. It's saying, work with your vendors, set common goals. That's a hard thing because traditionally people think, my vendors are out to hurt me, I'm out to hurt my vendors, and we're going to try to get the best of each other. You've got to set common goals. You have to trust each other. I'm not naive enough to believe that anybody's going to totally trust a company they work with, but in fact, that potential exists to start developing a trust that what they're telling you is the truth. That's a huge step right there. If your suppliers believe the schedule you're giving them is true, you've overcome, that's a major hurdle. It's probably half the work. You want to establish commitments. What are you going to do? If I'm buying globes from this guy and maybe I have 3 different suppliers and I'm always playing them against each other, maybe I go to one and say, look, I want to give you all my business, but you have to be able to do this for me. I'll tell you up front how many I think I'm going to use in a year, and I'll even commit to a number close to that. But you, in turn, have got to be able to provide me in the batch size I want, in the time frame that I want, and work with me when there are problems. Those are the kind of things you do. And you make an agreement to share information and work together. That's what a vendor partnership is all about. With the liquid detergent manufacturer, there were a number of people that blew bottles for them. One of them was very, very supportive and said, look, we're a little nervous about sharing all this data, but we're going to work with them. The other one said, well, let's think about it. We're going to form a committee. We're going to talk about it. We're going to kick it around. A year and a half later, the one company is getting all the business because they aggressively pursued it. The other one is still talking about it. They're going to be out of the picture someday because they weren't willing to trust. They weren't willing to make the commitment.
We were then controlled by our suppliers rather than being able to work with a supplier. Our effort has been, we've got a lot of work to do yet in this area, our effort has been to try to establish long-term, honest, reliable relationships with many suppliers as opposed to one supplier.
We have several suppliers that have committed to JIT. They're working well with us. We have some that don't really understand JIT, and we doubt that they're going to get on board, and we doubt that they will be suppliers to us in the future because we need to react fast. We will give them schedules, we will work with them, but we just don't have the tolerance for people that don't understand how fast we need to operate today.
So that's going on until the morning starts with the procurement group. The demand group is now working on what I call uniform plant loads, taking all this demand data and figuring out what rate should we be producing at. We said just-in-time means produce at the rate that you sell. Then now you have to figure out what rate do we sell so we can produce things at that rate. This is an example if this company, for instance, made 32,000 units a month. A lot of gumball machines. 32,000 units a month. They ran 20 days a month. That would be 1,600 a day. If they were a one-shift operation at 8 hours a day, they'd make 200 an hour. What that all equates to is 1 part every 18 seconds. If that were the volume here, that would be very high for a gumball machine. But what that would mean is every 18 seconds, in theory, in the perfect world, one of these would come out off the line. One of these would come out of the process. What that serves as the clock for the whole plant. It means anybody who's doing something twice to each machine, if I'm making a part that there's 2 of in this machine, or maybe the feet here, there's 4 of these. That means we're making a machine every 18 seconds. If I were making 4 feet every 18 seconds, it would mean every 4.5 seconds I'd have to produce one of these things. That becomes the time that binds the whole plant together. Now, and everybody for the first time can answer the question, am I building at the rate we're selling? If you went today and asked some guy painting legs, are you painting at the rate you're selling? He'd have no idea. He's saying, no, I'm painting at the fastest rate I can paint. Probably he'd say, I'm painting at the standard. They said I can do 300 an hour, that's what I'm doing. Uniform plant load says, don't do that. Don't work as fast as you can. Work at the rate that you sell. If you don't, you're going to accumulate material somewhere down the line. You're going to build up material. If you work too fast, you're going to accumulate stuff, and you're going to either have to pay somebody to store it for you, or you're going to have to pay your customers a discount to take it.
We had always been under the impression to achieve the lowest possible unit cost, that you should run everything at 100% of capacity whenever you can. But really, we found that we don't need 100% of capacity, and we haven't designed it to run at 100%. We're running at 75%. And what that's allowing us to do is to shut lines down and pull people off and train them, put them in the classroom. Never even dreamed of doing that before.
Once this is done, once they've calculated the UPLs and done this, they can now develop their smoothing plan, their design simplification, their deproliferation plan.
As before, inventory just sit around, and the packers would have a certain length of bats, and they couldn't ship the orders without the others. No one cared about the assortment loads. And now we have assortment loads, and the packers pack them all at the same time now, and then they can fill the order and ship it right on out the door.
The timelines have gotten a little bit longer. We're in the middle of the night now. People have been going 24 hours. They're tired. 24 hours, they're tired. 24 hours, they're tired. Morning's coming, the sun comes up, it's day 2, so we're ready to go again. You might want to change your shirts to let everybody know that you've only got 24 hours. Now it's just got to happen in 24 hours. Just as a little visual reminder to everybody what's happening, what has to be accomplished. So day 2 kicks off with probably have a little meeting, probably have another little status meeting, a pep talk, so everybody knows what's happened, shared all the information. Operations is implementing some of the changes that they made. Preventive maintenance is being implemented. The need for cross-training should now be apparent. You set up yourselves. You know what has to be done. You now know that there are different skills required. People have to do jobs they haven't done before. You might as well start the cross-training right off the bat. Cross-training means the goal is that you want every operator to be able to do every job in his area, and you want to reward people, motivate them for that. Just as an aside, I had a chance to go through a plant in Ireland that makes crystal, and it doesn't quite look like that anymore, but it's surprisingly not that dissimilar. And this plant is the ultimate in non-cross-training. In this plant, when you come in on day 1, and you're usually 16 years old, your 16th birthday, you hire in, you decide whether you want to be a cutter or a blower. You can blow the crystal by mouth, or you can cut the crystal by hand, but that's your career. That's what you're going to do for the rest of your career. You can do one or the other. And on your 5th year anniversary, you're an apprentice until then. On your 5th year anniversary, you're given this piece called the apprentice ball, and then you cut it or you blow it. And if you do it to spec, then you're a master. If not, I guess you come back in a year and you spend another year as an apprentice and do it again. I wouldn't want to work in that plant because the cross-training potential would be terrible. But it's kind of the ultimate of non-cross training. What we want is a plant where people, everybody who works on this machine, if I've got an assembly cell or a machining cell, everybody can learn to do every job. It makes their job better, and it provides you a tremendous amount of flexibility. A lot of plants today have buffers because the one guy who knows how to do one operation is out on vacation, or he's deer hunting, or he's sick, and he's not there. So you got to just accumulate material for him. So you're going to start the cross training. You're going to start looking at what can we do for cross training, and start it. Assign people to whatever makes sense.
We've got extra time now that we can always teach, train on the jobs. They can learn to do different jobs. They have their skills, for doing that, and it really benefits the employees, as far as learning different skills. I mean, if it comes down and needs to do a job, he's done it, and he's already been qualified on it.
You can go on a different job. Say, for instance, if you was on your own job and you was to run out of work, you can go to another job where that have built up, and then you can help the next person on that job. GIT really is teamwork, and that's to help the next person where the work has built up. If you got work on your job, you can do it until you run out, and you can go to the next place. So that's the reason why I like GIT so far in this system. The different jobs like running the lathe, running the fan sander, packing, different locker, inspecting, all there in the back at the end of the line.
You also want to begin any kind of non-disruptive moves you're going to make. You don't want to make moves that are disrupting production, but anything that can be non-disruptive, you might as well start moving while the plant is running. If you're going to build any special benches or fixtures because of your cell plan, you might as well start doing them now. And you might as well prepare for the moves, the more major moves you're going to make at night when the production is shut down. So the equipment relocation can begin right at the end of the shift.
And then we just had one cell we just finished developing in the wood unit. It's about 10 different operations in this cell. 3 people are operating that cell. And the second day they operated that cell, 2 of those 3 people came to me and said, I really like this. I think the idea of, instead of standing on a job for 8 hours doing the same thing, and now 3 people moving around inside of the cell, doing all different things in an 8-hour day, taking ownership of that cell, is really interesting and challenging to them.
Meanwhile, planning and control, they're designing the material handling changes. They now know how the pull is going to work, how the material is going to be pulled through the plant. They're starting to think about the way they handle material. The traditional fork trucks, the traditional batching might not work anymore. Maybe they need to develop some prototype baskets or something, or little wooden boxes, or find something, send somebody out to the store to buy a little plastic basket that they can use. You have to be creative here, whatever it takes to be creative. You want to review that with the operators once you've developed the prototype before they go home, and then as soon as they go home you can start building those devices.
By getting our employees involved, by getting them to help plan, to help implement JIT, there was a different atmosphere in the plant. It became a better place to work. People started showing up more often than they had before. Even if they were a little sick, they started coming to work because they knew their job was needed. Under the old systems, you had a day's work behind you, and so everybody else could still go on if you weren't there. That's what it was planned around. Under JIT, the employee knows that if he's not there, the work won't get done, and no one will work. So it's put not so much pressure on him, but it's helped him realize the importance of his job and his input. This has been a life surprise to us, mainly because they have had a lot of input into their job. They've designed it. In the past, management and supervision designed the workspace and how things were to flow. But when the employees design it and implement it, they take great pride in what they're doing.
The pilot pull is now in place. You have the whole day to monitor the pilot pull, make any kind of changes, prepare new mechanisms, however you want to do that. But you can get started on that and see how you're doing, and then prepare for changes the next night. Meanwhile, the procurement team is reviewing the program with all relevant management people. They're going back and saying, okay, this is what we've decided. Maybe we're going to cut the number of suppliers down on this one. We're going to try to develop this kind of a distribution, this kind of a delivery program with this guy. They're going to review it with everybody that's been involved. And now they're going to have a supplier conference call where they're going to call up all the suppliers they talk to and focus on the ones they've selected and tell them what the program is all about, what they expect from them, get concurrence that maybe the paperwork is going to change, maybe the way they communicate with them is going to change. But they're going to have the whole day now to implement that new paperwork, to implement the order and receipt changes. It doesn't have to take a long time to make paperwork changes. Maybe it's as simple as taking existing forms and scratching things off, or maybe you start a fax program where instead of sending people things, you fax them things. I don't know but what they would come up with specifically, but if you get creative, you can come up with a lot of good things. Then they want to develop their continuous improvement strategy with the supplier. This is not a one-time thing. You don't want to just spend 48 hours and do nothing else. You want to continuously improve. You want to tighten that coupling with your supplier and get better at it all the time. So they're going to work on that all day. At the end of the day, they're going to make the last supplier conference call and explain to the supplier, this is what's happened, this is what's in place. Tomorrow morning, 48 hours from when we started, this is what you're going to see from now on from us. Maybe it's a temporary form, but this is what you're going to get. When we want material from you, this is how we're going to order it. When you send it to us, this is how we want it.
Probably our next major step is starting, now that we know where we're at as a company with JIT, that gives us a little more background and leverage to start working with our suppliers, and I see that being our next major project, is to start working closer with those people.
The demand team is reviewing the sales smoothing strategy with all their sales representatives. The design people are reviewing the design simplification plan with engineering. In this case, they're actually going to change the coin mechanism. And changes can take place very quickly in a manufacturing company. Don't let people fool you that it has to take months to do. In the auto industry, when we had problems with dealers, when a dealer noticed a problem in the car that was a potential recall, we could actually have little hardware changes made, implemented on the line, and packages ready to send out to the dealer in about 48 hours. And that's how quickly things can turn around when they have to, when there's a focus, when there's a need to do it. So it is totally conceivable that small design changes could be made to a product like this in a 48-hour period. And then finally, you're going to want to maybe pick your top customers and review your deproliferation plan with them. Go to your big customers that buy the most of these and say, we want to eliminate yellow as a color. You hardly buy any of them. Would that hurt? Would you still be willing to buy our product? Would you substitute green for yellow? And so you want to review that with them to get their feedback. And once you've gotten that feedback, you want to implement it. Again, you're always focusing on all these things. I want to put these questions up again because in all this design work, you keep asking yourself these questions. Are you solving the problem? Is it simple? Is it visible? Those are the kind of solutions you want across the board, not just on the shop floor, but also in the offices. Now it's 7 o'clock. The sun's gone. The moon's back up. We're really in the home stretch now. People have been at it for 36 hours. The changes, the setup changes, we've already made all the non-machining setup changes. Everything that's to reduce setup time on the selected pieces of equipment have been made. What we're now doing is we're going to tie up the machine shop or the tooling room or whatever we have. Any changes to setup on the equipment that required maybe reshaping the tool or maybe drilling out the fixture differently or substituting clamps for bolts, those kind of things are going to be done in this last night and installed before the first shift starts. Any kind of equipment rebuild, well, we've got 12 hours to do that. Not major equipment rebuild, but simple equipment rebuild. We're going to continue a second night of equipment cleanup. The changes, the relocation of equipment is going to continue. We're actually going to set up a cell. The goal would be to have a cell set up within 48 hours, and that's entirely feasible. Again, you're not going to do major pieces of equipment, but if it's just a matter of a machine with no foundation, that's just maybe you move a hydraulic line, maybe even simpler, you just move electricity, then by all means you can do that in a nighttime. And we've been part of a lot of programs where we only had 12 hours to move equipment because production had to start again the next day. Planning and control is focusing on building the material handling devices. How are we going to move production from machine to machine? What's going to go into the squares on the floor? The pull mechanisms are going to be complete. I call them Kanban squares. I must have had a lapse. Whatever kind of squares we want to use on the floor, however we're going to pull, we're going to put those up, and we're going to set up the inventory. So when they come in the next day, the squares will all be full, so they can start. The planning and control can also focus on inventory adjustment and relocation of inventory. You might as well use this opportunity. You might as well get the other two groups involved too, because they're really done for this last 12 hours. You might as well get them to come and help. Let's get some of this inventory off the shop floor. We won't need it where we've set up cells. Let's get it out of the way, and we'll have a clean plant, we'll have clean equipment, cells set up. It's 48 hours later, and we've done an awful lot. If you go back to that original list, all the things on there have been done. Now, it's not finished, but everything's been started. Everything has been started, and you can continue it. And you've started it in such a big way that it's hard to turn back.
If I was to give advice to someone studying the implementation of just-in-time, I would certainly encourage them to include their employees at all levels from day one. Once they've made a decision to go, include. Build teams, make them aware, let them show the benefit, let them share in the responsibility, let them share in the pride of ownership, because I don't believe that you're going to be very successful without their input. And certainly, in the early stages, your work's cut out for you to get over the resistance thing, so make them a partner. It works.
It would be hard for management to say, oh, that program just died, we were just kidding, because it's been so visible.
We're all a team of people. We're not management and labor. We're a team of people with a common goal, and that's to service our customers. We are doing a very good job at this point of servicing our customer, and I think not only management realizes that, but the person on the floor, the man on the job realizes that. The other thing that I really like about it is the high visibility of what's going on in your system each day.
Everybody's running around from the top management on down with these shirts on. It's obvious that the commitment to it is there.
In terms of other places, as far as giving them some advice if they started in the JIP, I think you have to have total commitment from the top, first of all. And we did have that here. Mr. Hillerty was strictly for it, also from the Deming philosophy all the way through JIT. And it takes time. Now, you're not just going to fall into it and everything just work right off the bat, but if you stay with it, you can gradually make it work. And
we talk to the people at various levels of companies that have come, and we find that the middle management, the lower management, the employees are desperately searching for things like JIT, but that the top management has a difficult time seeing the need to change. And they really, the middle people just are not going to get anywhere trying to force it up. It has to come from the top down. And that's the most basic thing we found in suggesting to people how to get involved in JIT.
I wanted to conclude with one thing, and this is the 50th anniversary of The Wizard of Oz, and this, and I guess what I've been doing with you can think of in terms of sort of like a trip down the yellow brick road. And, and a lot of the promises made kind of are like, somewhere over the rainbow, but I thought of the analogy, and it certainly is very clear to me that the trip that we've been on through this 48-hour JIT is a lot like the trip that was made by the characters in The Wizard of Oz. Now, we have this image of them walking hand in hand down the yellow brick road and all for common good, but in fact, they all went down there for their own reasons. They all went to Oz for their own reasons. They had one thing they were after for themselves, and that's one of the beauties of JIT, is that everybody involved with it can go there for his own reason. The characters are very similar. In fact, here are some of the characters. We've got the Tin Man. He's the guy that had no heart. Well, that's the financial guy, obviously. He's going along in the trip. He's got incentives and just-in-time. It makes his job simpler. It makes cost accounting much simpler. It gets him away from the mode of having to count inventory and all the things that he doesn't want to have to do. It makes his job simpler. So he's going down the yellow brick road for his reason. How about the Cowardly Lion? Well, this is the production control guy. He's the guy that is afraid to tell anybody his job isn't the most important, so he puts everybody's job the hottest on the list. he's got an incentive in just-in-time because it makes his job much simpler. He doesn't have to, he can put a job first in, first out, and they'll go through the system. So he doesn't have to be criticized for being the cowardly lion anymore. Who else have we got going down this little yellow brick road? Well, we've got the scarecrow. Here's the one with no brain who doesn't know what's going on. It's probably the plant manager, unfortunately. But just-in-time makes the plant more visible. It makes things more obvious. Anybody can manage a just-in-time plant better because things are visible. Problems, he doesn't have to have people to interpret problems for him. He can walk through the plant and see things. They're obvious to him. He gains a lot of knowledge. Who else have we got here? We've got, well, the main character. Who's the main character in The Wizard of Oz? It was Dorothy. Dorothy's the hourly people, the people on the shop floor. What do they want? They just want to go home. They just want to go home, just like Dorothy did. And this makes their job easier. It makes the time they spend there more interesting. It makes their goals clear. It makes what's happening in the plant clear. It makes their job a little bit more exciting, and they can get home. Now, the other characters you got in there, who do you have hanging over the whole process? You got the Witch of the West. And this is the competition. Okay, here's the competition that's always hovering around, always causing a lot of problems, throwing a lot of smoke, and just trying to make your life difficult. Really, this is the one that sent you on the trip originally. This is the one that sends manufacturing people down the yellow brick road looking for the things, all these grand schemes, all these new techniques, all the fads and everything, constantly harassing them along the way. Well, what are the lessons from The Wizard of Oz? One of them is, as I said, everyone goes down the yellow brick road for his own reason. And that's true in a JIT implementation, and recognize that. Don't think that everybody is going to just want to do everything for the common good of the company, because that's not true. I mean, people have their own incentives. If you can play on those, if you can work with those, you can do a better job. Here's another thing that's very important. Wizards aren't as great as they want you to think they are. Think of the wizard in The Wizard of Oz. What was he? He was a lot of smoke and mirrors. He didn't have any skills. He didn't have any power. Those are the grand programs. Those are all these new fads, these new techniques, the new ways of doing things. They're not all that great if you can't make them work. The fact is that you probably have the capability, just as they did, to do it yourself. You've got the strength. What did they find out in The Wizard of Oz? They found out that they had the capability all along to do what they wanted. The Tin Man had a heart. The Cowardly Lion had courage. The Scarecrow had a brain. Dorothy had the way to get home the whole time on her feet. So the reliance on the wizards for all the answers turned out to be not the important thing. And finally, you find out that the witches aren't so tough, are they? And the witch, at the end, a bucket of water did her in. Maybe your competition isn't as tough as you think they are. Maybe applying some very simple, basic things is all it needs to be very good. That's all it needs to be, the competition. I say there's no place like home because you've got the strength in your plant. The plant is home to a lot of strength. And those are where the answers are. They're not going to come from the outside. You might need the support to make it happen. You might need the support to see that and to guide you. And that leaves me with the last character that I left off this. And that was Glinda the Good Witch. Now, Glinda followed them along the whole process. She was right there with them along the yellow brick road. She was kind of off to the side, but she was always there supporting them. I kind of think of her as me, the consultant. Kind of always there, supporting, pointing out the strengths. And but I think The Wizard of Oz is a good analogy if you think of it.
I suppose that if I am to be diligent in my duties, I should consider the downside of JIT. I've never been asked what the downside is. I have never read what the downside is. I suppose the academics could tell me what it is, but I don't think at this point I want to find out. But we haven't experienced any